So this is the 6-2 warm-up. I will say this about it. At the top, this says use law of cosines to solve the triangle. Remember, quiz-wise, it's just going to say solve. You've got to know which method to take, okay? So if you're looking, I mean, it's not like you can do one wrong, right? You either can do law of sines or you can do law of cosines. It's not like one's going to get you the wrong answer. If you had the same triangle, you could solve it both ways. They give you the same answer. There's only one right answer to this, okay, especially for law of cosines. So if you were given, if you like think back to it, if you were given angle, angle, side, or if you were given side, side, angle, you used law of sines. And then for law of cosines, if you're given side, angle, side, or you're given side, 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 we use law of cosines. Okay, but again, you can't screw it up because you can only do law of sines if you have the side and the angle opposite it, or the two angles in which you can get the third angle and then would have those two things. So it's not like you can do it with the information wrong. But just keep that in mind because that'll help you like speed up the process. We're going to lag today. So I'm going to work through the first one, but the most important thing is that side, 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 which means if I go from cosines to sine, you have to make sure you start with what? The trick with law of cosines is you have to start, when you're given all three sides, you have to start with the biggest angle first, okay? That's if you switch. If you don't switch and you just keep with the law of cosines the whole time, no big deal. But if you switch from law of cosines to law of sines, you have to do the biggest one first. So it's just good to get into a habit of doing it. So biggest one is C, which means I'm going to do A plus B minus C over 2AB. And then again, in the calculator, make sure you group these. So negative, cosine negative 1, parentheses, 7 squared, plus 10 squared, minus 15 squared, divided by 2 times 7 times 10. And I get angle C is 122.88 degrees. That's the first one. And then you can switch to law of sines at this point because you did the biggest one first. Or you can continue with law of cosines. I'm going to switch to law of sines just so we get a quick review on law of sines since we haven't done that in like, I don't know, a day. So let's say I want to go solve A next. Then I would do A over the sine of A equals C, which is 15, over the sine of 122.88. 7 times the sine of 122.88 equals 15 times the sine of A, and then I'm going to divide both sides by 15. 7 sine 122.88 divided by 15, and then I have to second sign that answer, and I get angle A 23.07. So the other benefit of keeping law of cosines is that you stick with the side measurements that they gave you. You're not using any information that you brought into the problem. So my advice there is actually to stick with law of cosines. But if you start with your biggest angle, it shouldn't matter. So you can even use it to check it. At the end, the last one I got to find is angle B. So I'm going to do 180 minus angle A minus angle C. And I get 180 minus 23.07 minus 122.88. which is 34.05. All right, the next one is a side angle side scenario. So Cassie, sure. So the first thing you got to do is find the missing side, which is A. A squared would equal the other two sides added together. So B squared plus C squared minus 2BC cosine of A. So 4 squared plus 9 squared minus 2 times 4 times 9 times the cosine of 135. And I get A squared would equal 147.91. So I'm going to square root that answer. I'm not going to round it. I'm going to keep it in my calculator. And I get A is 12.16. So that's side A. And then this is where you can, again, you can keep with law of cosines. You could switch to law of sines, okay? And honestly, as far as using an information that you got, you're going to have to use it for both. So there's no perk over that. If you use law of sines, you need to use A, which is 12.16 now. If you use law of cosines, you also have to use A. So it doesn't matter. The benefit to using law of cosines is that if you, and it only is going to happen if you start with an acute angle. So if I'm given obtuse, again, I don't have to worry about it. There's no other way to get an obtuse angle. But if you have an acute angle and you pull in the sides that make up side-side angle, you could again be bringing in an ambiguous case that doesn't exist. Okay? It doesn't happen all the time, and you won't know if it's happening or not. So that's why it's safer just to stick with law of cosines. So if I want to find, let's say I want to find angle B, I would do cosine of B equals A squared plus C squared minus B squared over 2AC. And I get 12.16 squared plus C squared, which is 9 squared, minus B squared, which is 4 squared over 2 times A, 12.16 times C. And again, cosine negative 1, that whole thing. Carefully make sure you add in the parentheses. And I get angle B is 13.46 degrees. So then the last one I got to find is angle C, 180, minus the 135 they originally gave you, minus the 13.46. And I get angle C is 31.54 degrees. And you're going to see, like on your quiz, I just give you a line for all the pieces of information that are missing. I'm not going to tell you exactly what's missing. You're not going to like on the thing we did yesterday where I gave you like A equals B. Like you won't have that. Make sure you do this in an organized fashion. That the easier it is for me to find your work, more likely you're going to get partial credit. The neater you are, the quicker I grade, the faster you get your grades back. Okay? If you're all over the place, it's going to be really hard. It's like a scavenger hunt. Grading quizzes is not fun. So when you get the line, on that line, you're going to list them. Make sure I know the difference between your side A and your angle A if it's there, or side B and angle B if that's part of what's missing. And especially C, because C, capital, and lowercase looks the same. So you're going to list it for me, only the things that are missing. Okay, I don't need all 6 pieces, but you'll list it for me nice and neat so that I am happy grading quizzes. If I'm happy grading quizzes, you tend to get more partial credit. Everything goes in your favor. All right, and then the last one is the Heron's formula, right? The length. So the first thing I'm going to find is S, which is A plus B plus C divided by 2. 2.5 plus 10.2 plus 9 divided by 2. And I get 10 point, wait, did I do that right? Yeah. 2.5, 10.2, 9. 10.85. And then you're going to make sure that you do not use that rounded. You keep it exactly as it is, and you type that in square root of 10.85 times 10.85 minus A, which is 2.5, 10.85 minus B, which is 10.2, and 10.85 minus 9, which is your C. You could type it all in, but make sure that you give me at least those pieces of information. You're going to want to give me S, so in case you do it wrong or you round it, I can give you partial credit. And you're going to want to give me what you typed in your calculator for the same reason. You don't give me that information and you get that question wrong, it's an automatic loss of points, which should not happen. 10.44. It didn't say it, but it'll probably be either nearest 10th or nearest 100th. That's what it would be if it was nearest 100th. Questions on anything related to law of cosines? So obviously there's also the word problems. I'm going to go over a couple in the video, but any added ones to that? This is number 10 from the homework. 2 ships leave a port at 9 a.m. One travels at a bearing of north, 53 degrees west at 9 miles per hour, and the other travels a bearing of south, 67 degrees west at 15 miles per hour. Approximate how far they are at noon on that day and round your answers to 1 decimal place. So they're both leaving the same port, right? So I have the same starting point. If it's here, they're both leaving that same port. One goes north 55 degrees west. So I'm going north, which is up, west, which is left, 53 degrees. So that's that angle. The other travels at the bearing of south, 67 degrees west. So it's going south, which is down, and then west, which is left, and it's 67 degrees. So those were the measurements that stayed the same for everybody, right? What was different was the speed. Do you remember your speed, or did you look it up? No. Okay, so I'll just use this one. The first one is 9 miles per hour, and the second one is 15 miles per hour. So the speed's going to help us because we need the distance, but we don't label a side with speed, right? We need to know the distance traveled. So the distance is the rate times the time. That's the rate, 9 miles per hour and 15 miles per hour. What we have to figure out is the time. How do you do that?
Yeah. It says 9 a.m. and then it asks about noon.
Good. So it started at 9, and it wants to know where they are at noon, which means the time is what? 3 hours. I'm going to take this 9 and multiply by 3. That's 27 miles for that one. And I'm going to take this 15 and multiply by 3, and I get 45 miles for that one. So now I've got my distance traveled. This is 45. This is 27. And I can make my triangle here, here. And the question is, how far apart are they? Which is going to be the side I want to find. So I've got the two sides. I've got the two S's. But what I don't have yet is the angle across from the side that I'm looking for. How do I find that? What's true about all three of these angles? They add up to 180, right? So if I do 180 minus 53 minus 67, the inside angle is 60. Now I've got law of cosines, right? So if I wanted to find this side, x squared would equal the other two sides squared added together. So 27 squared plus 45 squared minus 2 times 27 times 45 times the cosine of 60. And then I'm going to type it in underneath the root so I can get rid of this one. Second square root, 27 squared plus 45 squared minus 22 times 27 times 45 times the cosine of 60. 39.23. And it's around nearest 10th, right? 39.2 miles.
Would it be a question about equation?
Sure. I'll tell you right now, you're going to have to draw something. Like, they're not all going to be given. I'm not saying you won't get any diagrams, but you're definitely going to get ones in which you do have to draw stuff. They will be similar to something that we've covered up to this point. So there's a lot of different banks. There are some practice problems on the quiz review, but it's not all of them. I'm not going to give you the exact one you're going to see. First of all, I change it up for each class and within each class. So they're going to be a little bit different. You're either going to have to draw, you're going to have to apply your parallel lines like we did with 6-1 stuff. Any other questions from this section? Homework? 3. All right, so this says to use the law of cosines to solve the triangle and then round to 4 decimal places. So B is given to you, in this case, A and C. If you want to draw the triangle, feel free. If not, we know this is law of cosines because that's side angle side. So the first thing I have to find is side B. So B squared equals A squared plus C squared minus 2AC cosine B. A is 42, C is 31, 2 times A times C times the cosine of 18 degrees and 35 minutes. And then,
Should we keep it in that form or should we convert it?
as long as it terminates, well, it's going to terminate, but as long as it terminates with having to write like 7 digits, then it doesn't really matter. But if you get something that's like 18.45678910, and you have to write that out every single time, it's easier to keep it in that format. So I would just do second square root 42 squared plus 31 squared minus 2 times 42 times 31 times the cosine of 18. Go second apps, get your degree. 35 second apps, get your single tick mark. And I get B is 16. Oh, wait. Oh, the numbers are different. They're not going to match. Remember, these are, I changed it. 16.02.
Yeah.
Oh, no. 0240, because it says 4 decimal places. Okay, so then I've got that, right? So this is where it's tricky because they gave you an acute angle to start with. If I switch to law of sines, I could bring in an ambiguous case that doesn't exist. And that's why it's safer to stick to law of cosines. So when I go to solve for angle A, I would say cosine of A equals B squared plus C squared minus, oh no, sorry. Oh, no, I'm right. a squared over 2bc. And I've got cosine -1 of b, which is the one we just found, 16.0240 squared, plus c, 31 squared, minus a, 42 squared, over 2 times 16.0240, 31. Make sure you open up those parentheses on the top. And I get angle A is 123.3541 degrees. Ooh. And then the last thing I got to find is angle C. So I just do 180 minus the 18 degrees and 35 minutes minus the 123.3541 degrees.
I guess like did one of the decimals wrong. So I got that, but it's the same as
It said that exact number was wrong?
that. 5.3540.
Okay. It's as easy as that, right? Because you're rounding, like, I don't know how nitpicky, how like if you're within a tenth and you've rounded, so you used a rounded number, like it didn't say to keep the 4 decimal places and you rounded that, you're going to be a little bit off. That's fine.
Yeah.
Like I'm going to be picky on the S of the area. Don't round that. Like that better be the exact same answer. But a lot of the other ones, like I'm not going to have you keep 4 decimals every time. It will take you an extra 10 minutes to take your quiz because you're typing in extra numbers. So you'll be like just a little bit off. And if I tell you to get this back into degree, minute, second notation, remember how to do that, right? So if it says 38.0626 and I go second apps back to arrow DMS, then it puts it back into degree, minute, second notation, which in this case would be 38 degrees, 3 minutes and 45 seconds. So make sure you know how to get it back into that format.
Whenever it's a degree in seconds, what is the
Yeah, like even your homework wasn't consistent, so I'll be clear, like it'll say it on the test to make sure you put it back in that format.
And how do you put it back again?
So take that number, like 38.0626, hit second apps, and the 4th thing on that list is arrow DMS. Hit that, and it will, actually that's, so when I round it, it changes it. If you kept it the same as it originally was, the answer that was there before, oh no, it's still the same thing, 45. One of them is 0.24, one of them is 0.36, but you don't need the rounding on the minutes, or the seconds. Sarah, you had your hand up.
So like the 45, did you round the seconds?
Yeah.
Okay.
Is there, because like, it's kind of the same problem you had, like, is there any reason why, like, for example, one of the answers I put, if I add different numbers, but.
And you kept it as 16.0240? If that's the case, then you should have the exact same.
For, what do you mean?
Like if you kept all 4 decimal places, then your answer should have been exactly what they asked.
Is that for the first part where you're finding, and no, I got the first answer right, but then when it came to the part of answering the angles,
Yeah.
like I got 113.8559, and the answer was 113.8557.
And you, in the actual problem, did you round what you got from the first one? Or did you keep all 4
No, I
places?
kept all 4.
It should have been the same.
Or I probably wrong.
Yeah, just be really, really careful. All right, so I have to tell you that this is a great standardized test question because it pulls in information from another subject, right? It pulls in geometry, but then you have to apply it. So that you have to know the properties of parallelograms to get through this problem. One of the properties is that opposite sides are congruent. So wherever, what were your numbers? You want me to do your numbers?
I had 27 for A and then 45.
Okay, so if you have A is 27, then this other side here is also 27. And if B is 45, then this other side here is 45. The opposite angles are congruent on parallelograms. And then the other, what was your angle?
116.
Okay. So if this is 116, the other piece of information you need to know is that consecutive angles are supplementary. So one after the other, as you move around, your parallelogram would add to 180. So if I did 180 minus 116, I get 64 degrees for the other angle that's there, right? So that's the first thing that you can, oh, that didn't, 68. No, oh, the number's different. Remember, this is going to be different. Okay, yours should have been 64, right? So that's, those already are properties you have to know. Then there are technically a lot of different triangles going on here. If you cut them so that they actually have two sides and an angle, they would look like this. So I could take this triangle here, and then I'd have this angle, I'd have this side, and then I have this side. So you have side, angle, side, 27, 45, and 64. And then that would give you, this was D. And then go the other way, this way, and you've got your other triangle.
Is D like the...
It actually says it up here, so I had to read it too. It says the lengths of the diagonals are given by C and D. It's the whole thing. It usually, if it's like, it will tell you that it's either half the diagonal or it will cut them in half, something like that if it wants it. But in the directions, it actually said it's the whole thing. So the same thing for the other side. This would be the C that you're looking for. This is now 45. This is 27. And this is 116 degrees. So law of cosines for both of those. The other property that's not in, that they didn't use, that they could use, is that the diagonals are bisected. So let's say that this was only 1/2 of that diagonal. You would have taken your diagonal and cut it in half, taken your diagonal here and cut it in half, but you didn't have to do that. You want me to work it out, or you're good from there?
I'm good.
Okay.
I have to go to Cosines.
Okay.
How do you get data again?
The consecutive angles, so one after the other as you move around, are supplementary because they're same side interior angles or consecutive interior angles. So this angle, this one and this one are going to be supplementary. This one and this one are going to be supplementary. This one and this. So as you move clockwise or counterclockwise around your parallelogram, they're going to be supplementary.
And then you did 180 minus 160.
Exactly. Yep. Any other questions on the homework? All right, so again, you've got a quiz review. I have to alter the, so it said the 100 or 120 whatever foot vertical tower is to be erected on the side of a hill that makes a 6-degree angle with the horizontal. Find the length of each of the two guy wires that will be anchored to 75 feet up the hill and down the hill from the base of the tower. Notice that in the figure, this should be 100. Okay, and then round your answers to one decimal place. So in this, I know that the vertical, which is this, is 100. Okay, which would be the same here if I needed it. And then it said that it was 6 degrees off. So like this matched with your horizon is 6 degrees. So now my angles like can be looked at, well, there's a couple different ways to look at it, but one way is the horizon, which is that dashed line, and mixed with the bottom of this picture would be parallel lines. So if this is 6, this is also 6. Those are alternate interior, right? So when you go to make this triangle here, this angle is your 90-degree angle plus the 6 degrees. So this would be 96. Then you have this is 100, and you have this is 75. So let's say that you want to solve for this one. Actually, let me call it A because it's already. And then I want to solve for this one. So you've got two different triangles. You've got this first one in which it's 96, 75, and 100. And then you've got this second one in which your angle here is now 9 degrees raised. So it's 9 degrees less than, or 6 degrees, sorry, less than 90. So this is 84. You can think about these being a linear pair too. They add up to 180. So that's your other triangle, like this, where this one is 84, this is still 100, and this is still 75. You know where to go from there? Okay, so law of sines using the side will give you both of those guy wire lengths.
The one that was like a square.
So I changed it a little bit, but and I'll post that. There are word problems on there. Remember that you're not getting the formulas, so you need to study the formulas. I'll post that link to the Quizlet for all the different cosines and all that stuff on there, the areas and calculators the entire time. So just make sure you're bringing the calculator that is the one you're the most comfortable with. If you want to clear the memory or just make sure you have nothing in programs, it'll speed the process along of me handing out your quiz because I'll check those. Just make sure if you clear memory, you've put it back into radians, and all of these questions have been in degrees. So be really, really careful.